Okay, good morning, everyone, or good soul day. So my name is Aina, I'm from Malaysia, and I'm in mission 83 on Habitat Marte Space Analog mission. My presentation will be about the power station. Okay, so this is a bit of the contents. Everyone's presentation will have this content, so I will not go through this. More of the content. So I'll start with my internal design. So as usual, all facilities present will have a circumference shape of 8 meters of diameter and 3 floors. This is what each facility will have. Each facility will be designed the same way. For the power station facility, we'll provide a dormitory with beds for astronauts, small kitchen and dining room, toilet, small vertical garden with plants for meals, a 3D printer, and specifically for the power station, there'll be a monitoring system, which includes the main power generation unit, the EVA vehicle monitoring and quality, as well as troubleshooting stations, usage and requirement of power for each facilities, and the quality of energy. Moving forward. So this is basically like to see like a full view of the power station and what it's connected to. So just bear with me with my simple image here. So the power station would have a solar farm and a nuclear farm. And I would also want to consider a wind farm despite the Martian atmosphere. I'll explain why later. So, okay, just bear my drawing as well. I couldn't find a picture of the dome. So there'll be 3 floors in the dome. The first floor is the astronaut hub, the sleeping area, the toilet, kitchen and dining room, plants and social room. So this is basically where everyone just hangs out, eat, and when they're done with their work, they can just spend their time on the first floor. And the second floor will be more of the equipment room. Most of the electrical equipments will be here. There'll be a sustainable resource and power research room, and as well a study room. So most of the research will be here in the second floor. The 3D printer will be here as well. The researcher will work here. And basically, any research about alternative energy or anything about power grid, it will be conducted here. The third floor will be more to the monitoring area, which is about the main power unit and the EVAs and protection systems. So for this design, especially for the power station facility, we have to be able to collect data from all facilities, main power generation unit and the EVA vehicle. We have to be able to detect failures and troubleshoot from the power station facility if possible. So if there's an issue on other facilities, the first approach will be for each facility to follow the protocol of troubleshooting. If that's not possible, that is when you would contact the power station facility. And we have to ensure safety and protective measures. On the second floor, which is the in-house research areas, is where we research on biofuels, increase utilization of batteries, usage of heat pump to utilize Martian atmospheric temperature to heat the space station, and to study on reducing energy losses. Also, 3D printers are used to aid on research purposes. This is, for example, building prototypes on battery design or other custom equipment or parts. Moving on, so a bit on the electrical side. So I've taken suggestion from David Swaza from Mission 78, because in this presentation, I want to touch more on the energy, the sustainable and the mechanical side. However, in a power station, you still need the electrical side. So I'm just doing a follow-up for David Swaza's suggestion. So the supporting technologies included in the power station, definitely data collection, detecting failure, protective measurements. This is what I mentioned before also. There's power statistics, quality of energy, and definitely detection of faults, including overvoltage, overcurrent, short circuit, atmospheric discharge, and energy fluctuations. An example of equipment, there'll be batteries, circuit breakers, fuses, transformers, protective relay, converters, and inverters. So these equipments will definitely be in the second floor and the third floor. If it's used for research, it'll be on the second floor. Moving on. Okay, so in the power station, I came up with this action plan. So basically, it's not really an accurate action plan. So the action plan is to include any worst case scenarios, whether accidental or extreme. So basically, in my head, it would be like at daytime, you would definitely use solar power. and nuclear power. And nighttime, we will use the solar power energy storage and also the nuclear power and an energy storage. So you can see two columns. One is action plan 1 and is action plan 2. So it just depends on the situation, actually. So this is just like a brief plan. It's not in detail. Of course, if we want to go in detail, there'll be a lot of calculations involved and a lot of simulations involved. So I've put mode of operation. There's 3. One is operating, means like normal operation. Then we have accidental. For example, if something happens like power storage is broken or a cable is broken, so what would you do? And an extreme situation. So extreme would include dust storm, blackout, maybe there's a dust devil, or any other situation that you can think of, any extreme situation, because we would always want to think of the worst case scenario so that we are safe on another planet. Okay, so I'll just go through a few. So for example, accidental, if there's a broken cable or half of the solar panels are not working, we would use the energy storage box, or we would go full nuclear. And then if the nuclear reactor requires maintenance, means we can't use it for a certain amount of time. It depends on how many reactors require maintenance. We'll use full usage of solar power during daytime, and the remaining nuclear reactors that's not in maintenance, we can use that as well. And definitely we use the power energy storage. And then same goes to the power storage. If it's broken, then we opt for 20% of number of power storage and power accumulator on site. And then we try to reprogram for solar to work in daytime and nuclear at night. Okay, so the extreme is a bit like, as I mentioned, it's very brief and very on surface. So if there's a dust storm, we'll definitely use flue nuclear power. And another action plan would be to utilize wind farm. If there's a blackout for some reason, we can use the full power storage. And peak period, for peak period, I would imagine it's something like if each facility starts to do some sort of experiment at the same time. So I would consider that as peak. So depending on the situation, we use a backup to run on full power of solar or nuclear power. If we are unlucky to experience a dust devil, we can use a use of power storage accumulator depending on damage percentage, or we may utilize wind farm. And there are other extreme situations which may or may not happen. Yes, so that's about it for this one. Next, I would talk about the applied technologies. So first would be the solar farm. So the reason that we would use a solar farm on a different planet is because it's renewable, it's clean, it's safe, and the sun is everywhere in the daytime. However, on Martian atmosphere, we don't get as much sunlight intensity as on Earth. So that's why we have to modify a bit our solar farms. So solar photovoltaic installations are predominantly arranged in multiple parallel rows of flat modules, which are aligned towards the mean maximum solar intensity. So basically what it's saying here is solar panels will face the area where sunlight is maximum. And some studies found that the optimal orientation for this is at high altitudes, where a vertical collector and horizontal reflector is used. I will show an image of this later on. And use of solar panels that have maximized total energy production. As of now, this is still under research. So what I mean by a vertical collector and horizontal reflector is we want to reflect as much sun rays onto the collector. So that's why we use a mirror, or also known as a reflector. This is just to maximize the sun rays that hits the collectors. And then for this specific design, we have a few design variables, which is the length of the reflector, the angle of the reflector that makes the window or the collector, and definitely the location. Next one is nuclear. So the reason we use nuclear is because for the same power output for solar and the same power output for nuclear will require just less weight, less mass, just to produce the same power compared to solar. So nuclear is very clean and very effective, and its power output is constant in time, meaning there's less risk of prolonged power shortages that could prove hazardous to a human crew. So equipment or device that's already in study by NASA is the kilopower reactor using Stirling technology, which is called CRUSTY. And a bit of explanation on this is kilopower is a small, lightweight fission power system capable of providing up to 10 kilowatts of electrical power. That is enough to run several average households and continuously for at least 10 years. So it's very long-term and it's very clean. And then for our power station, there would have to be 4 and or more kilopower units because that would provide enough power to establish an outpost. So for a space station, for about like 5 to 6 astronauts, so basically a very small one, you would need about 40 kilowatts. So this is somewhere that I've read from the NASA's website. But for our space station, which would be like, for example, if we have like 4 facilities, that's about 16 astronauts at least, you would need more than that. We would use more than 40 kilowatts of electrical power. And that is why we can combine solar power and nuclear power just to generate enough energy for the whole space station. Okay, next is another good thing about this CRUSTY equipment. This is the CRUSTY equipment in this image. So basically, the heat output of the reactor, you can control it, depends on the depth of the control rod insertion. So basically, when there will be a rod inside the reactor, this rod is, it will prevent the nuclear from reacting. So basically what you can do is you can control the depth of the control rod. So basically you can control how much heat output would that be. So this would adjust the rate at which uranium fissions happen, allowing the heat output to match the load. So if there's a way for us to actually control that from the power station, then we can control like maybe nighttime, we don't need much nuclear power, so then we don't have to use so much, or during peak periods, we can increase the nuclear reactions in the CRUSTY equipment. Okay, moving on. So wind. So understanding that the Martian atmospheric, it has low density. And it's also, the wind phenomenon there is not as strong as on Earth. However, it can still be very useful in a way. Wind is not to be relied as the main power source. It can complement the solar power. So the challenge for wind turbines to be used on Mars is, number one, is the temperature, because Mars is very cold. So depending on the material that you use as the mechanical blades, it could cause brittle failure on the blades. And the amount of windy phenomenon on Mars. So as I said just now, there's not much wind on Mars. There are wind, but it's not as strong as on Earth. So one way that we can utilize wind turbines is, it's a good utilization during dust storms phenomenon, because the surge of power generation should be taken advantage. And then we can use vertical wind turbine instead of horizontal wind turbines, which are capable of catching the wind from all directions. So instead of trying to be very fearful of dust storms or trying to like stay away from it, we can use that to generate and harness power. Okay, next is, okay, the material used on the wind turbines, especially on dust storms phenomenon, is they need to be light enough to self-start on much weaker forces than those most commonly used on Earth. And the next one is the amount generated depends on how powerful the winds they are exposed to are. So proper positioning is essential, as higher ground tends to be windier. So in conclusion, again, the maximum utilization of power generation is key. So finding the most aerodynamic approach, which depends on the type of material for the wind blades, the location of where you're going to put the wind turbines, and also the design is very vital if you want to use it on Mars. Next is, okay, the pictures are vertical wind turbines. They're quite different than the ones that we see, the horizontal one, which is, it looks like a fan. Okay, and then just to explain a bit on the text on the left, another challenge on wind turbine is the ability to withstand the fine dust during dust storms. So on Earth, if you have wind turbines, especially at areas which are, they have dust storms, or not dust storms, sandstorms, Dust can enter the gearbox, the generator, and the controller of the turbines, as well as they can damage the blades due to dust abrasion. So I found a solution and study by GE Renewables, that's a company by GE. In Oman's new wind turbine, they can handle sandstorms and desert sun. So basically what they do is they actually change the design of how the gearbox should be. There's like a covering or some sort of, it's like some sort of covering that doesn't let the sand go in. So we can utilize this kind of design to be used on Mars. Other possible resources to generate in situ or transported for Earth is definitely the Mars Oxygen in situ resource utilization experiment. This is to generate oxygen on Mars. The next one is the Sabatier reactor, which is to scrub the carbon dioxide from air and generated water to drink with methane as a byproduct. So this is another idea to produce a sort of hydrocarbon. And I know there can be questions like, okay, hydrocarbon is not clean, but methane can generate energy. It is also a form of alternative energy. However, methane is the lowest producer of CO2 and other pollutants among the hydrocarbon group. This is just a research idea, I think. So methane can produce energy, but it's not clean, but it's also a form of producing energy. So people, I mean, we could use it as just to power something that's really small, for example. Yeah. So another one is biomass or energy recovery from composting. So this is like just a question that I just came up with. I couldn't find research on this. Yeah, but biomass or biofuel will be an important aspect actually, because we already have humans living in the space station, so we can fuel whatever bioform from humans to use as a to generate energy. Next is the EVA vehicle. The EVA vehicle uses a lithium-ion rechargeable battery, that's battery, or use the graphene batteries for power. So the battery rechargeable grid is connected to the solar farm. Yeah, I think there's no explanation for this one. And next one is the heat pump for space application. So there's a study that is a research on using heat pump for space, especially space as space station that's orbiting. So what I thought of using is heat pump on the space station on Mars. Okay, so heat pump is basically like our air conditioner. It's just how you say, it's transferring cold energy, cold outdoor temperature, and then producing heat. So basically it's just opposite of how air conditioner works. So we know that the Martian atmosphere is cold. So if there's a way that we can take that cold energy, let it transfer through a heat pump and make it produce heat for the space station, that would be a good application as well. Of course, this is a very on-surface idea. There's going to be a lot of questions and a lot of like research and technological questions on this, but I feel like it's actually a good approach. Yes, okay, so next one is management. Okay, so for management, there will be the facility chief or the lead engineer or the engineering manager. So for these three, I put them in one slot because they sort of have the same responsibilities. The next one is researcher or energy engineer. Then we have the electrical engineer or any specialized engineer. And the next one is technician. Okay, I'll brief about each roles. Okay, so the positions on the astronaut profile. The first is the facility chief. Now, the reason that I put facility chief, lead engineer, and engineering manager together is because they have the same role in a sense that they take care of that facility and they take care of people living in that facility. So what they do is they manage, forecast, and plan resource. They develop and manage plans to achieve the power station's facilities objectives, ensure interfaces and deliverables are clearly identified, maintain responsibility for progress and productivity, and identifying any required corrective action. They have to understand each engineer's objectives on the job and assist and support engineers on achieving those objectives. And finally, to ensure facilities, equipment, and safety in the facility is monitored and in good condition. So overall, they would actually just lead in terms of, they become like a technical lead, and also they take care of people. So they need to be very people person as well, people oriented persons. Okay, moving on, the researcher and energy engineer. So what they would do is conduct research on the facility, approves and ensure on the procedures and experiment reports developed, ensure equipments are in good condition, including 3D printer, preparing comprehensive report covering investigation activities as well as findings, carry out site inspection and energy surveys, develop technical expertise in all matters to do with energy and environmental control. So researcher will just conduct research, they'll be on the second floor, and then they'll just take care of anything related to energy and environment. Next, electrical engineer or a specialized engineer, perform conceptual and detailed analysis and design as per design basis, mission specification, design codes and standards. So when we talk about design codes and standards, I know when you go to a different planet, you will have a whole new design codes, but there will be definitely a few design codes that will be similar on Earth, especially when you take equipment from Earth and bring it to Mars. So certain design codes will be still familiar to engineers. Next one is develop creative and innovative solutions that are reliable and cost-effective for problems and challenges when they arise. Next, designing, maintaining, implementing, or improving electrical instruments, facilities, components, and or equipment items. Writing reports and compiling data regarding existing and potential electrical engineering jobs and studies, and supervising or training project team members and working with technicians. So notice that I put writing reports there because I feel that in each job, it's good to have a paper trail or some sort of evidence that you've not only done the job, but that you see how you do the job, like the procedure that you work on the job. So if anything goes wrong, you know what went wrong, you can have like a lesson learned and you can improve from there. So basically, I think having a paper trail on any job, including research and electrical related stuff, is very important. Next is the technician. So technician is responsible for the upkeep of a facility, conducting quality assessments, scheduling repairs, maintaining inventory, and developing preventative maintenance procedures. They will do inspection on building, equipments, and systems to identify any issues. They will repair faulty equipment units and damaged structures. And they will conduct periodic quality checks on equipment and systems to ensure everything is up to standard. So I believe this is quite straightforward on technician jobs. Okay, so an astronaut training. So when we talk about astronaut training, I want to go on a bit more on the basics, the technical, and a bit more on how to stay isolated, because that is just important. If you're a good engineer, but you can't stay isolated, and there's an issue there as well. So the first astronaut training would be fundamental study on power generation on Mars, how it works. You need to understand the physics behind it and the power grid on the space station. Keyword there is space station because power grid on Earth will be definitely different than on a space station. Understanding life support system and facility interfaces, like how one facility communicate with another facility. Definitely you need to go through meetups, team building, and understanding each engineer's role. There'll be power grid study and architecture of space station. You need to know how the space station looks like, where is where do you charge the battery for the EVA vehicle, for example. Definitely you need basic etiquette and support and preparation on isolation living. And astronauts, we need to go through all the simulations for accidental, extreme, day and night mode of operations. And finally, understanding psychological effect and how to maintain good physical, mental, and social health. So these are a few videos that I collected here. Just on generating power on Mars, electrical grid, building and motivating engineering teams. This is good for the lead engineer to look up upon. Maybe a few videos on MOXIE or any other devices just to get to know that device, including also the Sabatier reactor. Okay, the next one is resources needed for 1 week. So I feel like this is quite constant. So to effectively run a habitat on Mars and create fuel, you need about more than 40 kilowatts needed. Okay. So in terms of food and water, the diet and amount of food to be consumed depends on the individual. Each individual has different weight, height, and they'll be doing different types of activity. So those things need to be considered. One person's consumption on food may be different than other person's. So daily consumption of food is 2,100 grams per person, and water consumption is at least 1 liter a day per person. So the power usage, the food, water consumption is subject to change. You will still need to have accurate and detailed calculation and experiments to be run. So this is just like a rough estimation. Moving on, okay. So guidelines to be provided to other facilities. So, okay, for this, okay, first one is to record and report the consumption of energy and brainstorm ways to control and or reduce energy usage. So what the power station facility would want is, we want to know the consumption of energy for each facility, because definitely each facility's energy consumption will be different. So we would need this for research, for data purposes. And then since you know about your facility more, if you can find a way to reduce the energy usage, then you can propose that to us, to the power station facility. Of course, we would advise you on this because we will know more about the energy and the electrical equipment that's used. Next one is the basic and early detection of troubleshooting skills and understanding procedure and preventive awareness. Next is request, outline protocol and step-by-step procedure and create report on use of EVA vehicle. This is for any facility that has they have to go outside for some reason. So this is to ensure energy is required and stored is sufficient, as well as battery spares are in good condition. There'll be a complete protocol in case of emergency. So each facility would have their own complete protocol. One facility cannot have the same protocol as another facility, because each facility would have they would have different hazards there. They would even look differently. So everyone would have their own protocol in case of emergencies. There's also frequent meetings with power station facility on energy research update. So when we conduct research on the power station facility, especially on alternative energy, for example, when I mentioned the heat pump, for example. So this alternative energy that is built in-house, they can be utilized by other facilities, especially when you need energy that is not too much. So definitely we would want to give you an update on this. Okay. So protocols. Okay, so specific protocols and routines of the facility. So the protocols that I underline are everyday protocols. They happen every day. So every day we need to follow these protocols. And they include protocol for daytime power supply and nighttime power supply. Next is protocol for accidents. It's standard of procedures for every accidental situation. And we have protocol for extreme incidents, standard of procedure for every extreme situation. As I mentioned before, we have to think of the worst case scenarios before it happens. So definitely there's protocols for every situation. Next is protocol on energy quality and energy audit. Basically, we need the statistics on energy usage, anything that's lost or stored to be reported and highlight to power station team every week. And finally is the protocol of power generation and grid expansion. So we have, okay, so imagine we have a colony on Mars. So we can't just stick to that colony. So basically we want to expand. So our power grid and our power generation needs to be future-proof in a way. So there will be a protocol for that, in a sense, like, for example, we would have like maybe there's a location where we would plant more solar farms, for example, and then there will be space for cables. We need to think about the future, basically. Yes, okay. So protocols on safety. So this is a bit like on Earth, actually. Protocol on crisis management and emergency response. What happens if there's an emergency? What do you do? Protocol on pre-job planning. Before any mission or any jobs, you need to pre-plan that. So this is required for any maintenance work or handling of high energy equipment, including the EVA vehicle. Protocol for immediate report of injury. Protocol on use of tools and equipment. This is tools and equipment from Earth or that is built on Mars as well. Definitely housekeeping, even though that sounds very simple, but it's so important also. Personal protective equipment, especially in the research or when you handle electrical equipments, those things need personal protective equipments. And observation and intervention cards. This is when, for example, if you see something that's wrong or something that's hazardous, and if you see that in your facility, you can observe that. and let the power station facility know if it's related to electrical equipments or anything related to energy generation, anything like that. Yes. So the last one is basically for other facilities, actually. Okay, so protocol for occupancy and entertainment. So what will be included on the first floor of the facility is definitely there'll be music. People can listen to music, video games. Everyone loves video games, support sessions. Everyone in the team would definitely have to be very comfortable with one another. They have to be very open. And support session is when you can talk about other things than work, talk about your problems. Of course, when you talk about your problems, it makes you feel better. Next is reading material, yeah, and a hobby section. Okay, protocols for food and microproduction. So there'll be a protocol on planting, maintaining and care and harvesting of food on the vertical gardens. So it would be better if we get the protocol to be approved or developed by the greenhouse facility. And if there's any issues arise, it'll be notified to the greenhouse facility, because I believe this would be something that's sort of the expertise on it. For us, you would just have a basic protocol on planting, maintaining, and harvesting the food. Okay, 3D printing. So 3D printed parts shall be used for aid in maintaining, care, and harvest of food. So basically, if you want to plant like a pot of a different design or a tool to harvest the food, of course, you can use 3D printed parts. And then there'll be protocols in types of material use and schedule of 3D printing utilization. Okay, so what I mean by this is when you have a 3D printing machine, there's a lot of materials that you can use in the 3D printer. You can get aluminum or plastic, depending on your 3D printer. And we will need to record the statistics of this, like which type of material is used more and on what item. The importance of this is to basically understand, like, okay, which material are we using more? Are we using steel more or aluminum more? I mean, sorry, steel or aluminum. So with this, we can understand, like, okay, if we need aluminum more, we probably may request for more aluminum powder in the future or something like that, because it's not worth it if you get the same amount of aluminum and steel if you're going to use aluminum more. Okay, so this is just an example. Okay, it's good to record all these things, especially when resources are very limited. Next is protocol on clean post-processing of finished parts. So when you 3D print something, sometimes the post-processing can be really ugly. I've done 3D printing before. It can be quite ugly, especially when you especially when you 3D print metal parts. So there should be a safe protocol for that. Sometimes you will clean the part and dust can be everywhere. So you need to keep it safe and clean. Next is pre-planning on any long lead time items to be prioritized. So for example, if when you 3D print, when you want to 3D print different parts, you can't print them all 10 in one go. You need to plan which one to print first, which one is prioritized. So perhaps maybe smaller items should be prioritized or long lead time items should be prioritized. So this requires some sort of pre-planning, okay? Next is technician I spelled researcher wrongly. Technician and/or researcher and energy engineer shall frequently use the 3D printer. Okay, so spin-offs. Okay, technologies and outputs that could be applied to Earth. So definitely the Sabatier reactor, it can be used to help in reducing greenhouse gas in Earth's atmosphere, because it absorbs the CO2 and then change that to methane. So it sort of reduces greenhouse gas in a way. And then alternative power generation to help combat use of fossil fuel as main power generation on Earth. Usage of 3D printers on low gravity environment. We study on how parts can be manufactured on Mars and how low gravity affects and changes the material properties of elements. Next is use of nuclear energy on Earth. How to maximize usage of solar panels. You change design variables on the reflectors or the collectors, for example. Next is wind turbine or wind farms used in challenging environments. For example, sandstorms or hurricanes and heavy storms. Of course, this kind of I would say disasters, although it sounds quite bad. Disasters, they do have a lot of energy also. So if we can take advantage of that, it would be good. And finally, energy from compostable material. So when I think of compostable, it's more to food. you can get energy from compostable food. Next is guidelines to be applied to daily life on Earth. So how to use sustainable energy resources, maintenance and improvements of sustainable energy resources, improve and control use of energy for daily activities, definitely constant research and improvement on sustainable technology, and then increase confidence of investors and government. Okay, so this is a bit more on Earth. We're talking a bit more for Earth side here. So increase confidence of investors and governments. So governments have to rethink and establish relevant environment and energy policies. So basically, when you've done research on sustainable energy and it's good enough that investors on Earth they have enough confidence to invest on it, then they will develop that on Earth. Yeah. Next is energy consumption management. Okay. All right. Okay, so impacts to sustainable development goals. So goal number 7, affordable and clean energy with all the solar panels and the wind turbines. Goal number 9, industrial innovation and infrastructure. Goal number 12, responsible consumption and production. And goal number 13 is climate action. These are my references used. And yep, that's all about me, personal contact and social media. So that's all for my presentation. If there's any mistakes or anything that you feel like you want to bring up, you can just bring it up. I'm happy to learn and listen here. Thank you.